Here we're going to look at how we form ionic compounds and more specifically how we can write their formula correctly. So a lot of this comes down to understanding the key principles of the periodic table and in particular groups. So we know an ionic compound by definition is formed from ions. So you've got the positive ion from a metal, and you've got the negative ion from a non-metal. So ionic, you need a non-metal and a metal. Now we also know about groups. So if you're in group 1 in the periodic table, that means you have one electron on your outer shell. For example, lithium. It's got 2 on the first ring and 1 on the outside. So that 1 on its outside, when it forms an ion, it will lose 1 electron to form lithium plus. It will not form lithium 2 plus because it won't lose 2 electrons. On a similar theme, oxygen is group 6. Therefore, oxygen has 6 electrons on the outside ring. So when oxygen forms an ionic compound, it aims to gain 2 electrons, and that makes oxygen 2 negative. Okay? So knowing positions on the periodic table, knowing charges of ions is really important, as you'll come to see. So I'll start with 1 or 2 examples, and then you can try some examples, and then we'll make it a bit harder. So for example, if I have lithium and I have bromide, they will come together to form lithium bromide. Okay, now lithium is in group 1, so it's Li+. Bromine is in group 7, so it's Br negative. Therefore, lithium bromide is like this. The charges balance. You have 1 positive to 1 negative. So this is correct. Okay? Now I'm going to do a non-example, so this is incorrect. Sodium is group 1, so sodium is 1+. Oxygen is group 6, so oxygen is 2 negative. So sodium oxide is not NaO. Because sodium's 1+, oxygen's 2 negative, that does not work. Instead, the correct answer would be Na2O. Because I need 2 lots of this, 2 positive charges for 2 negative charges. Okay? So I'm going to give you some examples now and see if you can work out what the formula of the ionic compound is. There are 3 examples here. Can you work out what the formula of the ionic compound would be? Pause it, have a go now, and then we'll go through the answers. So the answers are, I have 2 magnesium charges there, so only 1 magnesium, but it's a 2+, and chlorine with a 1 negative. So that would not balance my charges. Instead, I need a second chlorine. That's correct. Here, I need 2 silvers. And here, I would need 3 fluorine. So overall, I now have 3 negatives and 3 positives to make this balance. So these are your 3 answers. We're now going to look at some harder ones. Now, as well as just having single anions, for example, fluorine or oxygen or chloride ions, you can have anions where there's more than one thing. For example, the hydroxide anion. Now, this is all one thing together. So you have 1 oxygen, 1 hydrogen, and together they're both a negative charge. So you just treat that as one thing together. Another example is the nitrate anion. that all comes together as a package. So you've got 1 nitrogen and 3 oxygens. You can't just add an extra nitrogen or an extra oxygen because the ratios between them have got to be the same. Another example is you have the sulfate anion and you have the carbonate anion. So those 4 anions are ones that really you need to remember, and they'll help you a lot. So now we're going to do some examples using these anions. So my example I'm going to show you is magnesium 2+, add the hydroxide ion, and what will it form? Well, just like before, I've got 2 positives and only 1 negative, so I need to make sure that they balance. Now, I need another whole negative anion to make it balance, so I need another OH negative. So overall, that gives me this. Now this is really important that we use the brackets because the whole of OH, hydroxide anion, is doubled. This is wrong. MgOH2. This is incorrect because I've now got 2 hydrogens but only 1 oxygen. So I've now not got my hydroxide anion there. I needed really to double the whole thing. So when you're using these harder anions where you've got a combination, you've got to treat it all together so that the whole anion stays together, and you may need to use brackets. So I'll show you I'll put some examples there for you to do, and then we'll go through the answers. Try these 4 examples and then we'll go through the answers. So, if I've got 2 positives here, I need more nitrate anions. Therefore, I need to double all of that nitrate anion to form zinc nitrate. My next one, my charges match up, therefore potassium hydroxide is that. Again, my next one, my charges match. So my 2+ and my 2 negative are fine. However, this one does not match. Now, I need the same number of charges on both sides. So if I did this, I've now got 3 positives but only 2 negatives. This isn't correct. If I double the amount of sulfate, I've then got 4 negatives. Now the lowest common multiple for these both is 6. So therefore, if I get 2 aluminiums and make 6 positives, I would then need 3 lots of the sulfate anion to make 6 negative. So aluminium sulfate looks like this. We'll have more practice on this, but there's the general ideas.